Hello everyone. So in earlier section we have learned about collection framework. So there were basically collection framework is a collection of interfaces and classes like list, set and queue, and furthermore it is divided into different classes. So in today's section we'll learn about ArrayList and linked list class. So this comes under list interface. So we'll go through first list interface, what sort of methods and why list is used in collection. So list interface is the child interface of collection. If we want to represent a group of individual objects where duplicates are allowed and insertion order is preserved, then we'll go for list interface. And we can differentiate duplicate objects and we can maintain insertion order by means of index only. So in list interface, index plays a very vital role here. So there are basically 8 methods which are specified in the list interface. The first one is void add int index object O. So to add at the specified index object O. So in list we can add an object at the index provided. Next one is void add all int index collection C. So here the collection C will be added to the list. And the third method is object get int index. So it is used to get the object at a specified index. We can actually fetch that data with the help of this index. The next one is object remove and int index. We can remove a particular object from that particular index. Then the next one is object set int index object new. So its return type is object. So this method will return an object. So this is used to replace the object with new at the specified index. For example, if I have written object set int 1 and object abc, then abc will be replaced at index 1 with a new object. So new object will be overwritten at that time. The next method is int index of object O. This is used to get the index of specified object. We can get that whatever object it is displayed. So what is the index of that one? So for that we'll use this method. The next one is int last index of object O. So this will give us the last index of object O. So with this method we can get to know how many elements are there in that list. So last index will return us. Then the next method is list iterator. So this is used to get the objects one by one. It is basically used to move elements between the list. So this was about the list. Now we'll go to ArrayList section. So ArrayList comes under list interface here. So it is a class because we have not written I here. I means interface, and if we have not provided anything, that means it is a class. So ArrayList is a class and it is resizable or growable in array. It's a resizable or growable array. Whatever elements we can actually stored in this array list. Duplicates are allowed here. We can enter duplicates value. Insertion order is preserved, and we can store heterogeneous objects. Heterogeneous objects means we can store objects of different collections. So here we can provide that thing, and null insertion is possible in ArrayList. We can insert null object. And here we have got an important note that we cannot store heterogeneous objects only in tree set and tree map. Otherwise, in all the collection elements, in all the collection classes and objects, we can store heterogeneous objects in that. But in tree set and tree map, we cannot store such type of things because In tree set and tree map, objects are actually stored in the sorting manner. If we provide objects from different kind of collections, then it won't be possible to sort it. So to compare two objects, it must be of the same type. So tree set and tree map won't have heterogeneous objects. Now, ArrayList constructor. Here we have three type of constructors in ArrayList. First one is ArrayList AL equal to new ArrayList. So this will create an empty ArrayList object with default initial capacity as 10. So default initial capacity of any ArrayList is 10. If we are not providing any size, then it will create a memory area of capacity 10. Once ArrayList reaches its max capacity, it means we have 10 spaces and we have provided all the elements at 10 spaces. Now I want to insert the 11th element. At that point of time, ArrayList will be created with new capacity, and the new capacity is equal to current capacity into 3 by 2 plus 1. Means the new capacity will be calculated in this manner, that it will take the current capacity. If I have given it 10, then it will get 10 value here, then it will multiply it by 3 by 2 and the whole will be incremented by 1. If I want to create an array list with our size, means with our desired capacity, then there is one more constructor for that, that is ArrayList AL equal to new ArrayList int initial capacity. So here we are providing our desired capacity, that what sort of capacity we want. So in that case, ArrayList AL equal to new ArrayList int initial capacity will be used. So it creates an array list of desired capacity. The third constructor is ArrayList AL equal to new ArrayList collection C. So this will create an equivalent ArrayList as collection C. If we are having a collection object, so it will create the same size as that collection can provide us. So three types of constructors are there. Moving forward, this is the example for creating an array list. So we'll import java.util.star package as we write for any Java code. Then the class of this program is ArrayList demo. Then here main is started. We have created an ArrayList L, new ArrayList. So here we have created an ArrayList with name L. So its default capacity will be 10. So initially we can insert 10 elements in this ArrayList. Now we'll write as L.add A. So this will add A in our ArrayList. Then we'll write L.add 10. So it will write 10. L.add A. Since duplicates are allowed, so we are inserting A here. And the next one is L.add null. Null is also allowed in ArrayList, so we can add null. Then we'll display L. So in that case, when we'll do system.out.println for L, then it will display as A, 10, A and null. If I write L.remove 2, then it will remove the element from the index 2. Like it will started with the index will start from 0 always. So here the 2 element is A only. So A will be removed. So when we write L.remove 2, then from array list we have 4 element A, 10, A and null. Then A is at 0th place, 10 is at 1 place, A is at 2nd place. So this A will be removed from our array list. And again, if we'll write system.out.println for L, so we'll get output as A, 10 and null, since we have removed A from 2nd place. Then I have written L.add 2 comma m. So this is the index what I have provided, and this is what I want to replace from. So at the second place, m will be added. So, and then l dot add n, then I want to add n. So if we write system.out.println for the final array list, then we'll get this kind of, just hold on, then we'll get this kind of output. Like output will be a, 10, m, null and n. Since we have added m at the second place, so m is inserted after 10, a, 10, m, null, and at the last we have added n. So this will be added here. So this was all about the array list and list. So in the next section we'll cover the other collections classes. Let me know if you have any query or concern. Thanks a lot. Signing off, Chitra Singh. Bye bye.